Hi everyone, today we will discuss relative velocity. So let us see this. So in this relative, when we say relative velocity, so in fact velocities are not absolute. When I say you are moving with suppose 5 meter per second or 10 meter per second, so this is also measured with respect to some reference point. So if you consider, suppose this is your x-axis and this is y-axis, okay, and this is origin. So if you are moving in this xy plane, let us say with the velocity 5 meter per second, it means this is your velocity with respect to origin. So always the velocities, displacement, all these things are measured with respect to some reference point or the reference frame. So that itself is a relative quantity, but origin, its coordinate is 0, 0. So we don't feel like always saying your velocity with respect to origin is this, your displacement with respect to origin is this. So that we ignore or it becomes silent whenever we say that your velocity is this, your displacement is this, and so on. But when we compare the velocity of one object with respect to the another object, then we have to mention that it is the relative velocity of one object with respect to another object, or it is the relative displacement of one object with respect to the another object. Whenever the second object with respect to which we are calculating these physical quantities, if it is origin, in that case we ignore to always say that word origin, origin or origin. Otherwise we have to mention whether your velocity is with respect to some other person or your displacement is with respect to other person. So that's why separately we discuss this relative velocity. So let us consider this. Suppose there are two objects, let us say A as well as B. A is moving with the velocity VA and B is moving with the velocity VB. Let us say VA as well as VB. Now with respect to this origin, this is your origin here. With respect to origin, A is at a position of XA and B is at a position of this XB. You can say either the displacement of A with respect to O, it is XA, or displacement of B with respect to O, it is XB, because O is the origin here. So when, as I just now I told you, when I say A is at a distance of XA from O, I can ignore that O and I can simply say A is at a distance of XA or at a displacement of XA. B is at a distance of XB. Now from where? So from here it is well understood that with respect to some reference point or with respect to the origin. Is this clear? So those things can be ignored when we generally talk of all these things. Now if you want to calculate the displacement of V with respect to A is at XA and B is at XB. So B with respect to A. So B with respect to A is what? Only this much. So that will be equal to how much? This XB minus this XA. So B with respect to A. B with respect to A. We are calculating B with respect to, so first we will write B and then we will write this A. So B with respect to A, so it becomes your XB minus this XA. So that way we will write. Now see how these things are considered. So here with respect to origin, A is at XA and B at XB. The velocities of A with respect to B, velocities of A and B, let us say it is VA as well as VB. Well, as we are saying displacement of A is XA, displacement of B is XB. Similarly, let us say velocity of A it is VA and velocity of B it is VB. Now in the differential form, we can always write velocity A is equal to dXA upon dt, because dx upon dt is the differentiated form of the velocity. So we can write this dx upon dt in general. Displacement of A with respect to O is XA, so that becomes dXA upon dt. Displacement of B with respect to O, it is XB, so that becomes dXB upon dt. So that is this is the representation for the velocity of A and B, and this is your representation in terms of differentiated form, dXA upon dt as well as dXB upon dt. Now next, if you see here, so velocity, our intention is what? Our intention is to calculate velocity of B with respect to A. So displacement of B with respect to A, as we have just seen, that is how much? XB minus XA. Displacement of B with respect to, measured from A or with respect to B, with respect to A, it is XB minus XA. So the rate of change of this displacement, which will be called your velocity, that will be equal to how much? dxb minus xa with respect to dt, any differentiation of xb, because this is the displacement. This velocity of A velocity of A is how much? dxa upon dt. Velocity of B is dxb upon dt. So velocity of B with respect to A will be what? dxb minus xa upon dt, because this is the displacement of B with respect to A. So this will be the velocity of B with respect to A. So we can write in this way. So velocity of B, always we write this B first and then A it will be second. The reference point it will be the second, it will be written in the second position. So velocity of B with respect to A, and that becomes your dxb upon dt minus dxa upon dt, because when you differentiate it, these two parameters can be differentiated separately with respect to time t, so that it becomes dxb upon dt minus dxa upon dt. dxb upon dt it is vv, dxa upon dt it is va, so that becomes vv minus va. So these are the relative velocity of one quantity with respect to the another quantity. So this is, here we have considered this, we can say either algebraically or the differentiation wise. We have just used the notation for differentiation, otherwise we have not gone into the detail of this calculus method and all these things. So it is just a symbolic representation, because we write this velocity as dx upon dt, so we have taken advantage of that. Now here, so that was just a simple representation. Now if you consider the vector representation, how we calculate the velocity of B with respect to A using the vector method. So using the vector method, if you consider, so let us say O is the origin, okay, and again you have this point, this object A as well as this B. The position vector of A with respect to O, let us say it is RAO. When we say this RAO, so it is position vector of A with respect to O. You can also write ROA, either way we can write ROA. So position vector of A with respect to O. Similarly, position vector of B with respect to O, let us say it is RBO, and this represents what? The position vector of B with respect to A. Because here we have represented position vector of A with respect to O. So first we have written A, then O. So here also position vector of B with respect to A, so it becomes RBA. So that way, so this is your vector triangle, and from there we can have all these representation. O is the reference point. With respect to O, position of A it is RAO, position of B it is RBO, position of B with respect to A it is RBA. So if you consider, so these things are represented here, then velocity of A with respect to O, that will be what? The position of A with respect to O with respect to time t. So we can write this drao upon dt. Similarly, velocity of B with respect to O, these are the velocity, as we have said, VA and VB. So when we say VA and VB, so either you can say that is absolute. When we use the word absolute velocity or absolute displacement, that is not absolute. In fact, that is not absolute. That is also with respect to origin. But when it is, anything is measured with respect to origin, so in that sense, we can use the word absolute. That is the only thing. Otherwise, all these physical parameters, they are always relative, they are not absolute. So here, velocity of A with respect to O, so we can write drao upon dt. Similarly, velocity of B with respect to O, it is drbo upon dt. Means position vector of B with respect to time t. Differentiation of position vector of B with respect to O, position vector of B with respect to O with respect to time t, position vector of differentiation of position vector of A with respect to O with respect to time t. These are just the symbolic representation. Otherwise, casually if you want to say, this will be what? Position vector of A with respect to O. Let us say it is xa. Then what will be the velocity of A with respect to O? If this is your position vector, we can ignore the writing this O here. We don't write O always. So position vector of A with respect to O, if it is xa, then velocity of A with respect to O, simply we can say it is dxa upon dt. So same thing in a proper symbolic form, we can represent like this. So these are your representation, velocity of A with respect to O, velocity of B with respect to O, and so on. Now let us see what happens. So from the triangle addition, here if you see this, this is your O, this is A, this is B. So we can consider this, again this diagram here. This is O, this is A, and this is B. Let us consider this. Now in this triangle law vector, OA plus this AB, that will be equal to how much? OB. When we say OA, head of this vector is this side, plus this AB, again this, that will be equal to your OB. This is the vector triangle addition. So OA plus AB, it is equal to OB. So OA plus AB is equal to OB. From this you are getting AB is equal to how much? OB minus OA. So OB minus this OA. OB means what? Position vector of B with respect to O. So that becomes your RBO. OA means position vector of A with respect to O. So that becomes RAO. And that becomes finally position. So OB minus OA or AB. AB means what? B with respect to A. So position vector of B with respect to A. So that becomes your RBA. Position vector. We are having two terms here. One is the position vector of one with respect to another. Another is the relative of one with respect to another. So when we are using this position vector of one with respect to another, so if you want to calculate position vector of B with respect to A, so first we write B and then A. So in case of position vector, this is the representation. Okay, but in case of relative of B with respect to A, velocity of A with respect to B, we have written what? VAB. Similarly, displacement of A with respect to B, it is XAB. Similarly, displacement of B with respect to A, it will be XBA and so on. So position vector of B with respect to A, so we can represent like this. So you have this relation. Now, AB is the displacement of B relative to A. AB is the displacement of B relative to this A. AB means what? This is the vector here. AB is the displacement of B with respect to A, and RBA is the displacement of B. RBA is the position vector of B. Position vector, we are writing first this and the second parameter in the second place. So RBA is the position vector of B with relative to this A. Okay, so the velocity of B relative to A will be how much? VBA. Velocity of B with respect to A, velocity of B with respect to A. B with respect to A, this way we write, that will be your VBA, that is DRBA. Here it is velocity BA, so obviously it will be position vector BA. So DRBA divided by DT, or with respect to T. Similarly, so again if you explain, again if you write all this, let me clean this. So again if you elaborate this RBA, so this is your RBA, that is RBO minus RAO, so RBO minus RAO. Now differentiate it separately. So DRBO upon DT minus DRAO upon DT. From there you get VBA, this is VBA, this one, that is equal to VBO minus VAO. VBO minus AO. Now here, once we have this again O and O is the origin. So we can again ignore and simply we can write it as it is VB minus this B. O we can always ignore. Unnecessarily we are writing O and O again. So it can be simply written as VB minus this VA. So VBA, velocity of B with respect to A, it is VB minus this VA. That's why when you are observing this vector representation, as well as we have observed that simple, either algebraic or using the calculus, we find that a relative, when we come to this relative concept, we always have this minus sign, not the plus sign. Relative of B with respect to A. Why it is VB minus B? Why not VB plus VA? You can have this question. So just to answer your confusion or this question, you can see all this method. We have this vector addition, from there we get this AB, from this we get this minus sign here because of this vector representation, and because of this minus sign you have finally this VB minus this VA, not VB plus VA. Relative does not mean the subtraction. So it is not necessary that we should have VB minus VA, XB minus XA. But why this minus sign is coming, that is just because of this vector representation, because it is the relative of one quantity with respect to another, because it is related to the position vector of one quantity with respect to another. We use the concept of the vector triangle, and that vector triangle gives us whether there should be a plus sign or there should be a minus sign, and from that finally we conclude that the velocity of one with respect to another, it will be, if it is suppose B and A, so velocity of B with respect to A, it will be VB minus VA, not VB plus VA. Other way, if you want to understand in a layman's voice, if you can consider. So let me discuss this. Suppose you have this x-axis and y-axis. Okay, A is moving, let us say A is moving in this direction, and B is also moving in this direction with the velocity VA and VB. Okay, just a simple concept I will tell you how to consider all these things. A is moving with VA and B is moving with VB with respect to this origin. So VA is the velocity of A with respect to O and velocity of B with respect to O, that is VB. O is supposed to be at rest. O is supposed to be at rest. So we are considering these quantities VA and VB. So that is with respect to a fixed reference frame or with respect to a fixed reference point. Now you want to consider the velocity of A with respect to B. B is moving. B is not at rest. So if you want to consider the velocity of A with respect to B, so first you have to bring B at rest. So first we have to bring this B to rest. Now why B is moving? B is moving because it is changing its position with respect to O. B is changing its position with respect to O, and that's why we are saying that B is moving. Okay, now, so if you have to bring that B to rest, it means B should not change its position with respect to O. That means O should start moving, and if this O should start moving with the same velocity VB, let us say O is moving with the same velocity this VB, then what is the velocity of B with respect to O? Can you see it is at rest? If I am moving with 5 meters per second and you are also moving with 5 meters per second with me, will there be any separation between us? Either it will be equal to the initial separation always, or if we are moving parallel to each other from the same position, it means the separation between us, it will always be 0. Because you are moving with the 5 meters per second and I am also moving with the 5 meters per second. So no gap, no separation is created. So it means you are at rest with respect to me or I am at rest with respect to you. So if B is moving with the velocity VB with respect to O, now O has also started moving with the velocity this VB, it means B is now at rest with respect to O. Now when B is at rest with respect to O, then only you can compare the velocity of A with respect to O. So what is the velocity of A with respect to this moving O? Velocity of A with respect to moving O, can you say now it will be VA minus this VB. So velocity of A with respect to moving O, it becomes VA minus VB. Now who is at rest here? B is at rest. Now A is moving as well as O is also moving, but B is at rest because here it is VB here, because we were comparing the velocities of A and B with respect to O. Okay, now O has started moving with the velocity VB. So what is the velocity of B with respect to 0? So A is at rest with respect to O. But what is the velocity of A with respect to this new change situation? O is now moving with the velocity VB. So what is the velocity of A with respect to O? It is VA minus VB. In fact, it is not the velocity of A with respect to B. It is the velocity of A with respect to moving O. But in the inertial frame, we don't compare the velocities with respect to non-inertial frame. Here B becomes the non-inertial, O becomes now the non-inertial frame, and B becomes the inertial frame. So with respect to this A, yani velocity of A with respect to B at rest, because now O is moving, B is at rest. So what is the velocity of A with respect to B at rest? And that's why VA minus VB. So in a simple language we can understand like this. Otherwise you have all these concepts and we can calculate the displacement of one object with respect to another object. We can calculate the velocity of one object with respect to another object. So that way we can always calculate the velocity. So this was your one-dimensional motion. That is, the velocity of A is, let us say, along x-axis. B is also along x-axis. So very easily we have calculated velocity of one object with respect to another, or the displacement of one object with respect to another. Now if there are two-dimensional, similarly you can have the three-dimensional. So our study is restricted up to two-dimensional right now. So we will see what happens when two-dimensional motion are concerned, and when we how we can calculate the velocity of A with respect to B. So these are again the vector representation that we have just discussed. So you can have this AO, then we have this velocity of A with respect to O, velocity of B with respect to O. Similarly, you will have this vector triangle, and from that we can take this opposite as I was just discussing right now, and from there we will get this vector triangle, and from that we have calculated the velocity of B with respect to A. It becomes VB minus this VA, and that was the vector difference here, you can see. Now let us see what happens when the movement is in two-dimensional. Let us say there is a particle which is moving with the velocity u along x-axis. This line is just parallel to x-axis. Here it is O, here also we have named it as O because this line is just parallel to this line. So suppose one particle is moving along this line OC with the velocity u, and another is moving along this line OD with the velocity v at an angle of alpha. Then how to calculate the relative of, let us say this is the velocity of A and this is velocity of B. Then how to calculate velocity of B with respect to A. Now what we do here is velocity of B with respect to A. This is needed. This we have to calculate. So can you say, if it is suppose vector representation, velocity of B with respect to A. So it means we will have velocity of B with respect to A along x-axis. First we will calculate velocity of B with respect to A along x-axis, and then we will calculate velocity of B with respect to A along y-axis. It means calculate velocity of one object with respect to another along x-axis, calculate velocity of again one object with respect to another object along y-axis. Once you have this velocities along x-axis as well as y-axis, what will be the resultant velocity? Then in that case, can you say it will be equal to your VBAx whole square plus VBAy whole square root. As in case of vector addition, or the resultant of vector, we have x square plus y square square root. This always gives us the resultant of the vectors. So velocity of B with respect to A we want to calculate. They are in different directions. calculate separately along x-axis as well as y-axis their relative velocities, get the resultant. You will get the velocity of b with respect to a. This is the simple way, and this is the most simplest way that we can calculate the relative of one object with respect to another object. With you can prefer the vector method, you can prefer this analytical method. This can also be considered as the component method, because we have calculated x component of the velocities, we have calculated y component of the velocity, and just using the concept of the vector addition we have calculated the resultant, so that finally we can calculate velocity of one with respect to another. This is the simplest method, this is the best method, and I will always suggest you to prefer this. When you use the vector method, sometimes you will come across certain confusion. To get out of all those confusion, just resolute all the velocities along x-axis and y-axis. Calculate relative of one with respect to another along x. Calculate relative of one with respect to another along y. Once you have calculated this x component and y component, you can always calculate the resultant. Now this resultant velocity means the velocity of b with respect to a. Let us say it is along this line. Just it is an assumption, and it makes angle beta with the x-axis. Suppose this is your VBA. If it makes angle beta with the x-axis, then this relative velocity, what will be there? Because once it is velocity, so you have to calculate magnitude as well as direction. Magnitude we can always calculate using this direction. So if it is suppose beta, then when you are dropping this perpendicular, this is what? Y component. This will be your x component. So tan beta, that will be equal to how much? Velocity of b with respect to a along y-axis divided by velocity of b with respect to a along x-axis. So you can calculate this beta. So tan beta it is equal to VBAY upon VBAX. So using these concepts, we can calculate the direction of the relative of one with respect to another. We can calculate the magnitude of one with respect to another. This is the best possible method. We call it as the component method. We call it as the analytical method. And always I will suggest you, if it is not one dimensional, if it is two dimensional, just use this concept and we can calculate any type or solve any type of problem. Now here, if you see this discussion here on the board, so again, this is u along this and v along this. So obviously its x component will be how much? V cos alpha, and its y component will be v sin alpha. So velocity of b with respect to a along x-axis, it will be how much? Vb ax. That will be your v cos alpha minus u. V cos alpha minus this u. Similarly, velocity of b with respect to a along y-axis, it will be how much? V sin alpha, because this side it is v sin alpha. Y component of a it is 0, so it will be 0. So v sin alpha minus 0. Now these two quantities are known. So resultant it will be how much? This square plus this square root. So that way you can calculate the magnitude of the relative of one with respect to another. So here you can see this. V sin alpha minus 0, the y component. You can see this v square is equal to this square plus this square. Finally you are getting this. Obviously tan theta it will be how much? Y component and divided by x component. Always try to be logical and try to use the effective way. So tan theta it will be y component divided by x component. This becomes your y component. This becomes, there is nothing to memorize, there is nothing to keep in mind. It always, you know the vector addition, you know the resolution, you know how to calculate the resultant. Everything is same. So there is nothing new. Two particles are moving, one is moving along one direction, another is moving along some different direction. We will calculate the x component of all the velocities or displacement. We will calculate y component of all. Once I know the x and y component, I can always calculate the resultant using the my vector concept. Similarly, once angle of the resultant vector or angle of relative of one with respect to another, when y component is known to me and x component is known to me, then tan beta is always y component divided by x component. So that's what we are doing here. So y component divided by this x component. So that way we can calculate. You don't have to use any trick, you don't have to memorize things, always try to use the concept. Except formula, you should not remember anything. Except formula, you should not remember anything. There is no need to go for any shortcut method. There is nothing like shortcut method. There is nothing like tricks. Simply you have to depend on concept. If your concepts are clear, you will be able to solve any problem. Otherwise, you won't be able to solve problem. That is a clear-cut funda. So this way you can calculate. So we have calculated the angle, and once y component, x component are known, you can calculate the resultant of it. So this way you can calculate the velocity of one particle with respect to another, even if it is a case of two-dimensional motion. Thank you.